Now that we have connected all the components to the breadboard, and have written code to make each component work independently, it's time to put all the pieces together and build the complete kit. Before we start, let's first list what all we want to do in this kit. 1. Check if there is an obstacle detected in front of the IR sensor. If there is, then display this fact on the top line of the LCD display. 2. Measure the distance of the nearest object in front of the ultrasound sensor. Display the distance on the second line of the LCD display. 3. Write both these values, that is, obstacle detection and distance, to the Cloud Firestore database. Let's start looking at the code now. Start Arduino IDE. First we need to import libraries for this project. In this case, we need to import two libraries, one set for the LCD display. 2. One set for Firebase. We have already seen how to import libraries in the modules for LCD display and Arduino Firebase, respectively. We then define constants for different pins. This is the same as what we have already done when writing code for the individual modules. We also have defined a variable for the LCD display class called QDisp. This is again the same as what was in the LCD module. The lines in the setup method are the usual lines. We initialize the serial port, set pin modes as either input or output. Then we initialize the Wi-Fi router details and Firebase connections. Remember to replace the const char values with the actual values for your connection. Now let's move on to the loop function. In the first few lines, we are checking whether there is an obstacle or not. We assign this to a Boolean variable called isObst. The meaning of these lines has been explained in the module.ir sensor. In the next few lines, we calculate the distance from the ultrasound sensor to the nearest object, and assign it to the variable called distance. The significance of the lines of code are explained in the module titled Ultrasound Sensor. We then print the obstacle detection status and the distance onto the serial console. The next two lines, we write these values to the Firebase real-time database. Firebase.setBool sets the value of a key to either true or false. Firebase.setFloat sets the value of a key to a decimal value. Finally we set the two lines of the LCD display to A, status of obstacle detection, and B, distance respectively. That's it. Let's go ahead and test the code. Make sure the ESP is connected to your computer. Verify and upload the code. Open Serial Console. Move your hand close to the IR sensor. You should see three things. 1. On the serial console, the obstacle detection status is set to 1. 2. On the LCD display the first line reads obstacle ?03. In Firebase console, the value for the key obstacle is set to true. Place some object in front of the ultrasound distance. You should see three things. 1. On the serial console, the distance of the object. 2. On the LCD display the second line reads distance equals a number. This number is equal to the object's distance. 3. In Firebase console, the value for the key distance is set to the value of the actual distance of the object from the sensor. Hooray! We have completed this project. Let's move on.